Hello, my name is Solden Stoll. I'm 13 years old, and this is my 2018 Breakthrough Junior Challenge application on the partial derivative. I chose the partial derivative for many reasons. For one, it's a key topic in math and has applications through all higher math. Along with this, it's also a key topic in physics, and believe it or not, has applications in biology and life sciences as well. Before I explain what a partial derivative is, you should have proper knowledge on what a derivative is itself. A derivative of a function is an expression that represents the rate of change of that function with respect to an independent variable. This is also the slope at any given point of that function. Here's the equation for a derivative. Now that you know the basics of derivative, it should be fairly simple to learn what a partial derivative is. A partial derivative is a derivative of a function in 3 dimensions, but with a different notation. So let's say we're going to take the partial derivative of a function with respect to x. What this would basically be doing is slicing the function down the x-axis at a given y value and taking the derivative of the resulting 2-dimensional function. Here is the equation for a partial derivative. If you compare this equation to that of a derivative, you'll find that they're very similar. The only difference is that the partial derivative is with multivariable functions. Don't worry, if you do not understand this now, here's an example that should clarify it a bit more. For my example today, I'm on top of this grass mound in my neighborhood. I chose this mound because it resembles the function f of xy equals negative x squared over 20 minus y squared over 20 plus 10. So we're going to be taking the partial derivative of this with respect to x, and then going to the point we take the partial derivative at and checking our work. So this is a graph of that function. We'll take the partial derivative at the point 3, 0. To take the partial derivative, we can use the power rule. If we use this, we get negative x over 10. Evaluating this at x equals 3, y equals 0 gets us negative 3 over 10. Now I'm approximately at the point 3, 0. This is where we took the partial derivative of this function. What we got is a slope of negative 3 over 10, which is also a pitch of 13.5 degrees, which seems about right. So there you have it, the partial derivative. It isn't so complicated after